class. So we're going to continue with the examples for chapter 6. It's on interrupt. So let's see what example that we have this morning. So given a circuit, there's two switches connected to two pins of port P, and then you have LEDs connected to port C. Now of course the example that I'm giving now is something to do with port C and things like that. But take note that it's not limited to only LEDs. You can also do 7-second and so many other things. You can do a lot of things. So write a program to configure switch 1 and switch 2 to high and low priority respectively and enables its interrupt. When switch 1 is pressed, lower nibble of port C should turn on the LEDs, whereas when switch 2 is pressed, high nibble of port C should turn on the LEDs. So what can you understand from this question? Don't worry about writing. This way the discussion. What do you understand from this question? Then there's two interrupts. So how you then? There are two interrupts. And what else do you understand from the question?
It's two interrupts.
I just told there's two interrupts.
The lower nibble and the high nibble.
Lower nibble and high nibble. Lower nibble means what?
4 bits. 4
You know 4 bits of which one? Lower nibble means what?
0 to
Yes, 0, 1, 2, 3. That's lower nibble and high nibble is 4 to 7. Get yourself thinking out loud. The reason I'm asking you to speak out loud is to think out loud. Express what's in your mind, and that's the best way you learn. I tell you why. Short story is one Wednesday morning. When I was Form 3 studying for PMR, I had this charity tuition class. So there's a teacher who actually came and he taught me this one chapter in science, a whole chapter which I have not learned in school yet. But in the whole chapter, he actually taught the students, he told the students, whenever I ask you, he'll tell, I forgot what chapter is that. I think it's about the elements or something. So he told, I'll teach you this. Then when I ask you back, what is this, you answer. I teach you, then I ask you, you answer. And you should answer by shouting. So you should answer by shouting, don't shout here. You should answer by shouting. So he repeated the same thing for every single thing in the chapter. You know one thing? That chapter I never studied after that. That 1 hour, he actually taught the whole chapter. I understood it until I finished PMR. And after that also, I remember. So anyway, that's why it's always good for you to actually say something. Even though it's wrong, it's okay. But you're training your mind to bring out ideas. That's why I keep asking you, what do you understand? Just whack lah, whatever you understand. What you see, question. You better prepare yourself, then you go to finals, then you start thinking what to think. I don't know what to think. See the question, you don't know what to think. So at least now you are training yourself to think. But of course, if you don't want to think, then no one can force you. Nothing can be done. So let's write the program. Now we are going to have two interrupts, right? What should I write here? Don't worry about writing. This way the discussion. What should I write here? Huh? You can give other name also. now in the beginning of the program, what should we do? Is there anything for us to configure? What do we need to configure? Yes, port C. So how do you configure port C? Port C as input or output? Output. So how do you configure port C as output? Yeah. So clear as release. And then is there anything else you want to configure? How about port B? Do we need to configure? No, the one you configure later as interrupt, not as a normal input output. Is there anything you want to initialize? Port C. What do you want to do with port C? You want to clear port C to make sure that all the LEDs are off initially. Is there anything else you want to initialize? No. So the next thing what you can do, you can write the instruction to configure interrupts, right? Now here we have two interrupts. We have two interrupts, right? So what is the first source of interrupt? 90, second one? 91. So you can do it one after the other, so not a problem. So what's the first thing that you need to do? You need to actually enable the priority scheme, right? What's next? You know that it's both interrupts actually belong to the core group. So you need to configure, let's take interrupt 0. What do you need to do with interrupt 0? Clear the which bit? Yes. Where is the flag for interrupt 0? Then because INT0 doesn't have priority, next thing we need to do the enable bit. Where is enable bit? Also in incon, so you need to set now what I'm going to do is I'm going to do the global one last. So I've already configured two control bits. The next thing is the control bits for INT1. So you need to clear the flag, right? This is for 90. So you need to clear the flag. Where is INT1's flag? Which info? 3. Flag is clear. And then the priority. What do you need to do with the priority bit? Clear. Yes. Why need to clear? Why need to clear? Blue. Yes, because it's low priority. And then the enable bit. Income? 3. So we're done. Now we need to also settle the global one, right? So what do you need to do? GIE or GIEH? Is it done? What else missing? So now both is done, right? So you configured both interrupts. Now what do you need to do next? Finally.
You have to do the
Witness for what? Huh? For the? You don't need to do bit test because you already configured it as interrupt. You're not using polling. Wait.
So basically,
Yes, you should wait for interrupt. So be clear on that. Huh? When you're using polling, then you do bit test. Now both is actually configured as interrupt, so you don't bit test. That is also another mistake that student always will do in the final examination. Make sure it's very clear in your mind that if you're configuring as interrupt, you are going to use it as interrupt. Don't go and bit test it. Like yesterday, it's a combination of interrupt and also the polling. So for the polling one, you bit test. Then for the polling, respectively, you need to set the bit also. You need to make it as input for the switch. Is it okay? So here, what you need to do, you need to wait for the interrupt, because the main task got nothing, no other task to do. You just wait for the interrupt. Can I erase this one? So we need to write the subroutine now. So how many subroutines we have? Two. Right. The first one. So what's the first thing you need to do? The interrupt service routine? Yes. You should always clear the flag. After they clear the flag, is you have to do whatever task that you're supposed to do. So for the first switch, what's the task you're supposed to do? Turn on the lower nibble. So how can you do that? So you move literal value. What's the value you need to move? 0F, and then you move it to is there anything else you need to do? Yeah, before you return. Is there anything else you need to do? No. So next thing is you can return from interrupt and enable back the global. Any question up to this point? You also have the second interrupt, right? What's the first thing you need to do? Complete. What is the task you need to do for this one? What's the literal that you have to load? So does it look difficult?
So just curious to ask, shouldn't the INT0 be the high nibble?
INT0 is the high.
If it's the high, shouldn't it be F0?
Come again?
If it's high, shouldn't it be F0?
Switch 1 is actually for lower bit, right? What did I write the question? Switch 1 is lower nibble, right? Yes. So lower nibble correct lah? 0F. how are you going to turn on the LEDs? This is 0 F. Any other question? Any other question before I explain the program?
F is on what? That's why you're moving the value.
No, you think of F2 is high enable, right? So you load to this one, high enable LED. So it means lower and higher. Now you put 0F. 0F means this is 0, F is 1, 1, 1. So only these 4 LEDs will turn on. The lower neighbor, because this is arranged like this, you tend to think the other way around. So when F0 means here is F, here is 0. Higher neighbor, lower neighbor. So the lower neighbor LEDs will turn on. When you press the 1, the higher neighbor will turn on. Just that now sebab dia macam ni, you will have problem. It happens. So see this program. Okay, this part no problem. You already enable the interrupts and then wait for the interrupt to happen. That means your PC will actually keep looping here. So when you press switch 1, it will stop, it will save the next address, and where it will go? Automatically it will go to 08. It's a fixed thing. I means to come 08. 08 is say go to ISR. So come here, you clear the flag, go on and return back to interrupt. So you come back and continue back here. Then if you press switch 2, it will stop, it will save the next address. Automatically it will come to 18 because it's fixed. Low means it will come here. Then come here, clear the flag and load the lower neighbor and return back. Keep waiting. Simple. Is there any question? If you don't have any question, then I'll ask you a question during this too. Okay, talking about test 2. You all have test right on Friday. Do you have test on Friday? Yes. Next Friday. So next Friday is holiday, right? No. How about something when you can see? This Friday your time lah. Next Friday got test. I just want to ask, during the Thursday tutorial, all of you having clashing. That means B cannot come to the A. What time is the first tutorial? Thursday? 1. So all of you have class on 1 to 2. Thursday 1 to 2. Who having class Thursday 1 to 2? You have class. Okay, if Friday we can't make it means, but they have tests, then most likely then we'll have to end up having tests on Thursday. So I'll make 2 sets of questions, one for the first. Okay?
So next Thursday. Yeah. Can we have the project show next week?
Yeah. We'll make some changes to that. One of those. Any question? So I know we have the project to do, but we'll make some changes. What to do? Because it's Friday, you all have classmates difficult. Then you have to make some changes. But still, this Thursday, which is tomorrow, we will start using the process. Any question on this? Okay, in chapter 6, there are two examples of interrupt. It's in the textbook. The slides also, I'm not so sure, I can't remember. There are two examples. If you see at the end of chapter 6, there's actually two examples of interrupt. One is using interrupt, one is actually using INT0, but if you see, that interrupt source is not a switch. That interrupt source is actually connected to a timer, 555 timer. You know what's 555 timer? Huh? You don't know. It generates a periodic signal, bistable and everything you learn. So it's actually a timer. It actually will create a pulse. So it means now instead of connecting a switch, it's connected to a timer which generates pulse. So it's the same concept. The same concept. You still have to enable the. That means it is as if someone is pressing the button with a constant period. That's what it means. Basically. So that's why I say this interrupt thing. You don't have to limit yourself to the input as switch or the output as LED. It could be anything. This could be anything. But the principle of how you configure it and how the interrupt happens is the same. So don't get confused if you see any other question which is different. So what I want you to do is see that example. There are two examples. The second example is using timer interrupt. So hold that example first. We go to chapter 8. We learn timer. Timer will learn in two aspects. One is you use timer as a timer. The second one we use timer to generate interrupt. Two things you see. So you see the first example. See the question. Do not see the answer. I know you'll see the answer anyway. But try to do the question without even seeing. Just follow the same way and then compare your answer. Okay? There are only two examples at the end of chapter 6. I'm not so sure it's in the slide. Yeah, this one. But the question is not here. I think the question is not here. Right? So you see in the textbook, chapter 6, last one. It's timer. It's on page 265. Page 265. Okay, can I make, is there any question? Otherwise I'm going to make quick changes. Okay, let's say the question now we change. Assume the same question, but both also is configured to high priority. Same question, but both of the interrupt is configured to high priority. So what are the changes that will happen here? This one don't have. This one won't have. This one any changes?
No.
This one any changes?
Yes.
Which one? Not like that. So any changes?
Yeah.
Then you wait for this one, right? This one any changes? This whole thing. Now take note that either one of the switch you press also, it will go to 0 8. But how you know which switch is being pressed? It will go to 0 8, either one, because both also is configured to high priority, right? So it will go to 0 8. You press switch 1 also you go to 0 8, you press switch 2 also you go to 0 8. So which means what can you actually do here to find out which switch is being pressed? Yes, you can use bit test. What do you want bit test? Keep it set or keep it clear?
Skip is set.
Set. Keep it set.
Skip is
Clear.
set.
Keep it set or keep it clear?
Set.
Keep it clear. Because you want to check whether the switch is pressed or not. So you're going to check for flag. You're going to check for this particular bit. If it's clear, you skip. Clear means what? Pressed or not pressed? Not pressed. Take note that you are not checking the condition of the switch, you are checking the flag. The logic of the switch is yes. When you're not pressing, the logic of the switch is 1. When you press, the logic is 0. In interrupt, when the flag is 1, it means the button has been pressed. So if it's clear means the button has not been pressed. So what do you do if it's clear means? You check for the next flag, which you skip right. So here, we test. So what can you do here? Skip is set or skip. Clear? What do you want?
Set.
You want to keep it set. This is equal to 3. 1. So if it's set means you do something. If it's not set means you won't skip. What is supposed to do? If both also is not pressed. Check. Right. Go out lah. Right. Both also not pressed. Right. Okay. So go out. Why you want to exit? This is most likely won't happen lah. The reason I come to interrupt me, one of it is being pressed. But assuming that in case if both is not pressed, why you want to go again check back? If both not pressed, you go out, you exit. So here you exit. This one, skip if set. That means press means you skip. What is supposed to do here? This is switch 1, right? Sorry, switch 2. Switch 2 pressing, what are you supposed to do? Huh? I enable, right? So move LW F0 WF to or C. After you do this, what are you supposed to do? Repeat. Return. So you easy. This one for one part settled already, right? Second switch. Skip if set. That means if it's pressed, it will skip. Then you do this. Then you go out. If it's not pressed, it won't skip. It will go this one. That means if you already come this spot means both is not pressed, so still you exit. This one, you check the first one. Skip if clear. Means if the first one is not pressed, you check for second one. Second one, if it's not clear also, it won't skip, it will branch exit. So here is, if it's pressed, it's supposed to do something. What is supposed to do? LED, but here got one line, so we can't do that. So you use after this, schedule it by right. So here is where you can put your Okay, another thing I forgot. If this one is on, one thing I forgot. If this one is pressed, what's the first thing that you must do? Yes, you should clear F and T on 3 flag. You should clear flag first. Same goes to this one. Here you should clear the flag. I forgot that one line. Is it okay? So that means whenever the interrupt happens, because both are actually high priority, so when it comes here, you need to check which one is being pressed. So how you check? By checking the flag. So you check for the first flag. If not pressed, you check for second one. If second one also not pressed, you exit, turn back. But let's say assuming one of it you press, we check this one. If this is pressed, it won't skip. It will go to the next one. So branch upper LED. The branch upper LED, first thing you do is clear that flag, and then you load the value for the upper and you go out. Likewise, when the second button is pressed, you will come here, check. If this is not pressed, it will skip. This one is pressed, so it will skip also. Then it will clear this flag, and then you load this value, and then you exit. Any question on this? End of chapter 6. So take note that the knowledge of doing interrupt already is passed to you. Likewise, by using this technique, it doesn't limit you to the number of interrupts. You can have unlimited interrupts. But just that how you manage those interrupts. So again, let me just remind you, what I've just given is an example of using a simple input-output using the switch and also the output as an LED, but that is not limited to switch and LED. The output could be anything, the input could be anything. So I've given you the concept on how to actually configure the interrupts, how to actually use polling and interrupt together, how to use more than single interrupt, and how to actually also do a single more than one interrupt which has the same priority. How do you do that? So I've already given you different ways on how to do that. Basically, these are all the concepts in interrupt. Of course, there are many more. So the next thing is by you doing exercise. Take past paper, see how the question is being asked, how to interrupt, and then the example in that particular page in the end of chapter 6. See the question and try to do. They'll see whether you understand or not. Take note that the LEDs in that example using a NOT gate. So don't simply just whack the output LED, don't just simply whack to 1 minute to turn on. So first study the schematic. What logic is required to turn on the LED? When the switch is given, what logic happens when the switch is pressed, not pressed. And take note that here the flag is 1 if the switch is pressed. It's not the logic of the switch. When the interrupt happens, the flag becomes 1. Is there any other question?
So just to ask, just to clarify again, BTFSC skip clear is when the button is not pressed, and when BTFSS is when the button is pressed.
Okay, there's no question. Thank you very much. Naveen, can you stop recording? Okay, test 2 will go until chapter